Testing. 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 All right, and our microphone works. All right, welcome to another stream. Today we are on our Linux computer, a break from the Windows computer, and we're also going to be taking a break from paper reading. Today we are going to be doing some coding. What we're going to try to do is we're going to try to make a NeRF, a neural radiance function. It's called neural rendering with ChatGPT, with the help of ChatGPT, and we're going to do it from scratch. Scratch implementation, of course, is going to be also the simplest possible version of that, but let's do a little bit of programming today. So first thing we're going to do is we're going to go on our GitHub, and we're going to go to our repositories. Actually, it looks like I might need to sign in here. So now that we are signed into GitHub, go ahead, go to repositories. Let's make a new repository. Call it Nerfito. All Nerf. Make this public. Add a README. Of course, we're gonna MIT license. Let's go ahead and create that repository. So now we can go here, copy this, dev folder. Nerfito. Nerfito is like a diminutive suffix that you can add to words that means the small version of that thing. That's where that comes from. All right, so let's Ito. Okay, now README, we have our license. Let's go ahead and open up. Let's make it bigger. And again, we have Copilot integrated into VS Code. So here in the bottom corner, you can see looks like a little pilot, but that means that it's activated. Open up. And and let's say a tiny minimal implementation of NeRF. You can link this find the so to create links, README files, you this basically bracket and parentheses. That might be the other way. It might be parentheses brackets. Go to our channel, Upo here live. We can copy this. Up, copy, close out. Okay. So ahead and that Control-Shift-G will open up the Control-B. This is the sidebar in VS Code, and then Control-Shift-E is the kind of file browser. Control-Shift-G is the GitHub. So go into the GitHub commit here. They updated README with YouTube. Commit this change to our changes. Sign in using GitHub. Okay. Okay. Signing in happened. If we go back to here and we refresh, we should see Nerfito updated. And if we go into the commits, you can see that we're properly committing with our Hupo GitHub account. Okay, so we have a new public repo here. I'm going to give it a little star. It has a README, has MIT license. We committed to it from our... So now let's do brainstorm. So what framework should we for this project, right? PyTorch, TensorFlow, or JAX? Those are basically the three options. Answer this question. Go to the papers with code. They have a very useful visualization here. You actually go to the trends. They have a picture here, and you can see the different frameworks. So this is basically all the different projects and what framework they use. So we can see here that TensorFlow is slowly dying here. Tell that since 2018 all the way to 2022, very few people use TensorFlow. JAX, which also comes out of Google, like TensorFlow, is actually has grown over that time, but it still remains very niche, and most people just use JAX for custom. Like what the advantage of JAX is the VMAP, which allows you to vectorize code easily, and then PMAP, which allows you to parallelize code easily. So if you're someone who has access to TPUs and you want to basically take your compute graph and kind of map it onto a complicated system of multiple TPUs, then I would say JAX is your go-to. But I think for us, for a small kind of minimal implementation of NeRF, I think PyTorch makes the most sense, right? PyTorch has grown in market share and it becomes more and more popular. It's what is used for a huge amount of the projects and stuff. All of the OpenAI stuff is in PyTorch. So I think we're going to go ahead and use PyTorch. Recording to the papers Look at that. That is eerily creepy. Auto completing. So we will go ahead and link that. Have our link. Go ahead and use PyTorch. So I generate. Yeah, I mean the cool thing about deep learning is that it's such a powerful hammer that you can basically treat everything like a nail. So if you just get good at deep learning and the basics of deep learning and machine learning, you can actually make significant leeway into a variety of different fields. Another one that I haven't touched, for example, is finance. Like machine learning in finance is huge now. Machine learning in anything dealing with text, right? So I think if you learn machine learning in one particular niche, a lot of it can be extended to other niches, and then your knowledge to solve problems everywhere, which is very cool. Okay. So we've gone ahead and made a choice of framework. Since we've chosen the framework, why don't we go ahead and make a file here. I call this file here. We're going to call it requirements.txt. And in our requirements.txt, we're going to pick a PyTorch. So first thing we're going to do here is ask ChatGPT, can you write a bash or a Linux terminal command that will tell me what version of Cuda I have? All right. So to check the version of Cuda installed on your system, you can use the following code. I'm going to copy that. There. Yeah. Okay. So on this computer, we have two GPUs. We have a 1080 and a 1070, both 8 gig models. And we have Cuda version 11.6. So we're going to go ahead and go to PyTorch. Start locally. We want a Linux, we want a pip installation, we want Python, and we have Cuda version 11.6. So we are going to install this one here. Here, readme install PyTorch with the following. Okay. So we will go ahead and that. Before that, though, let's go ahead and for that, let's create a virtual environment. PyEnv, virtual env. What version of Python? Say actually, why don't we just leave it at what it is? Go here. And you write a Linux terminal command that lists the available Python versions for PyEnv. PyEnv is a virtual environment manager that I'm using here in my Python environments. And Python install -l is that. Here are all the different Python versions. So we have everything up in 12, so 9, 3.10. Python 3.7, it is recommended that you use 3.6, 3.7, or 3.8. So let's go ahead and do a Python. Python 8. Call it Nerfito. And PyEnv activate. That. 8. PyEnv virtual. So it installed Python 3. So let's do this. And now let's activate our Python environment here. All right, so you hear leading part for this parentheses here. This lets us know that we're inside the Nerf. And now let's install our PiTorch. PiTorch second. Save that. And let's test our installation of PiTorch. Okay. Import torch. Torch.cuda is available. All right. PiTorch, as you can see, Cuda version gigabytes, so it's a second to download that, especially since we're streaming from this computer. Right. Name this dependency. Then we're gonna have a different section here. I'm gonna call this architecture. This section we're gonna kind of brainstorm what the different parts of our project are going to be. So the architecture of NeRF is as follows. Hub Copilot is not. It does not know what NeRF, but it's trying, and it actually did a pretty good job here with the virtual environments PyTorch installation. So I have two different, I would say the state of the art implementations for NeRFs. There is the one that comes out of NVIDIA here called Instant NGP. And then there is NeRF Studio, which is a open source implementation done by this guy here. Yeah. Okay, so current state of the art NeRF are have NeRF Studio called NeRF Studio. This one, and then the one is NG. Okay. So just kind of scrolling through here. Instant NGP uses Cuda 11.5. Instant NGP has like this nice little front end UI. Yeah. I've used this. I've not used NeRF Studio, but it does seem very popular. It has a lot of stars. They are very active, right? They're pushing code up until yesterday, so very active. Repo. So go ahead. Okay. PyTorch finished installing. Let's go ahead and check our PyTorch. Is okay. So we do have Cuda installed on the. Why don't we go ahead and install these. That we can the freeze. So we ask ChatGPT. Can you modify this pip command such that only the packages installed in the current Python environment are put into the requirements file? And is going to pip these in .tf. Okay, so pip freeze -- local requirements file. And let pip freeze -- and now if get only the stuff that PyTorch. That save file. Correct, except okay. So go back to our architecture. So we go to I think what we want is the original NeRF NeRF paper. So I think this is the paper here. And this is the chart that we want, right? And there's a couple different components that we need to have. So the main components for our NeRF implementation are, and we need a volume of space that is voxelized, right? So we need something that defines this little cube of space that where this Tonka truck is. We need a camera position and orientation. What else? We need a calculating the ray for each pixel. We need a the color and opacity for each ray, or the color and opacity at a point on each ray, right? So a ray is this red line, this red orange arrow, I guess, that comes out here. And for each pixel in our image, there is going to be a ray that goes through it. And that ray is going to go basically from the center of the camera. And it's going to project out through that pixel. And then it's going to traverse this volume of space. And we're going to sample along that ray on various points. And for each of those points, we're going to have a neural net that predicts a opacity, right? And a color. So have a neural network to predict the color and opacity. So the inputs, you render the image from a camera position. You're going to have a loss function for the rendered image and ground truth image. We're going to need a dataset loader for training and testing. We're going to need a dataset for dataset of images and camera positions. Watching, we have a little okay. What else here? That's most, of course, the training loop, training loop and testing loops. And we need evaluation. Input is a single continuous 5D coordinate, spatial location x, y, z, and viewing direction theta, phi. So let's about so inputs is the ray direction, the ray origin, right? Outputs are the color and opacity. So let's dive deeper into that. Ray direction is the direction of the ray from the camera. And in parameterized, this is obviously going to be normalized, but here they specify the view direction as theta and phi. Right? And those angles, so theta, phi, and the ray origin is going to be the position of the camera, going to be x, y, and z. So the output, you're going to have color, RGB color of the pixel, and the opacity is how much light is absorbed by the object, number from 0. So we're just going to take GitHub Copilot's suggestion here. This is 8 layers of 256 neurons each, I guess, for the MLP. That seems like a lot. Let's just 3 layers. And sure. Okay, look at that. So it's already kind of, you can see GitHub Copilot here suggesting input layer of 6 neurons, 3 for the ray direction, 3 for ray origin. This is actually wrong, right? The ray direction only has 5. Hidden layers of 2, 6, and the output should be 3 color, 1 for the opacity, which is correct. All right. That's kind of a little bit more about the neural network. Calculating the color and opacity of the ray. Calculating the ray for each camera. So I think maybe the next thing to do here is actually look at instant NGP, the actual source here. Well, these are actually files. Okay, so instant NGP might not be useful for us at all because written in a highly performant C++. I think NeRF Studio is actually PyTorch, so this might be a little bit more useful for us. Let's see, rays. describes region of space as a frustrum. So they have torch typing here as well. Torch typing is a way to add types to the different parts. So they have a couple different properties here. They have the start direction of array, the XYZ coordinates of array. So these are also three-dimensional, right? So I think that actually samples along array. Camera index, width of each sample, the start of the bin edges before warping is applied. Function to convert bins in distance. Transmittance is the relative sum of all the densities as you go through. Ray bundles, a bundle of rays. Camera indices of the unit ray direction. You have the ray origin. Times. That's all camera indices to a specified camera index. So there seems to be this notion of camera indices. Samples. That's a little bit of cameras. Let's look at the actual model. So base model. So they're using the torch.neuralnet class here. Have this base class here. A device returns the model, so this is like whether or not it's on the GPU. Populate modules, get outputs, get groups, forward. You have loss, get outputs from array camera bundle. Image height, image width. So I think the ray bundle object inside this repo is basically the collection of all the rays associated with a single image. So you can see that they've created this data type here, ray bundle, that allows them to easily kind of type these functions. Have these loops, right? Kind of for each ray in the ray bundle. There. Loaded model, blah, blah, blah. Okay, so why don't we actually go ahead and start maybe not with ChatGPT. And we need to decide different how we're going to structure this project. I think we're going to have a couple different files here. Going to have utils.py. We're going to have train.py. val.py. I think model.py class have forward function is going to be part of the class. Class function there. All right, in the utils, we're going to array sampling. Sure. We're going to have the volume sampling. We're going to have the volume rendering. In train, we have our train loop. We're going to have our test loop. Val generate one image from a camera position. So go ahead and file file NeRF. Of course, we're going to torch here. Neural net, we're NeRF class. Positional encoding, that's well. Have a make another file here, call it ut.py. Array and volume, not volume. So let's just probably better. Have a couple different array sampling, volume sampling. Have here train.py. So train.py script for the we're definitely gonna have argparse, probably OS as well. Torch, I guess. This I like never remember how to actually if come on, Copilot. There we go. Okay. So you know what we're gonna do? We know that we're ultimately want Hyperopt here. So in a previous project, what was it? Our bio project. Enzymes. We had optimize.py. At Hyperopt here. Okay. Let's actually go ahead and start writing Hyperopt correctly. So Hyperopt is a hyperparameter optimization tool. So basically, it allows you to run a anything function that produces a quantitative score, and it allows you to run it with a variety of choices for input parameters. And then when you do that, you can basically figure out which hyperparameter values are the best. And the thing with Hyperopt is that it's easier to just use Python directly, right? Such as this. So I think we just go directly Hyperopt and we skip the argparse, because argparse is kind of thing anyways. So let's actually go ahead and install Hyperopt. We are going to nope. Hyperopt port fmin so here's where we're gonna store our hyperparameter. Go ahead and there. Find the space. There's objectives here. This is not the right objective function. Obviously, this is for a enzyme project that we did. We're going to want actually of all this. From port we're actually going nice. So main script for function here we're bugging train and okay. Go back to our README, and what was the last thing here? We need val.py. Evaluate trained model. generating. Okay, so we're also going to have torch dependencies file. We're probably file. And maybe we'll add, but basically script as well. And in this, we load the model, correct. Then use a camera direction. Size of the checkpoint, choose position, and then choose the size of the image and load the model. Perform inference. Render the actually have matplotlib. Go ahead and reinsert matplotlib. Okay, so we've kind of made some of the boilerplate for our stuff here. Have an eval file. We're going to NeRF. Have a optimization file, kind of main file, and then file, which is probably going to be the hardest one to write, which is ray sampling, volume rendering, one. So other NeRF diffusion model. Maybe it was this one. But I think the main thing I'm looking for is this. All right, so implementation details. So if we actually go to train, one of the things we're going to need in our train function, call it LR, float 0.0. There's also going to be batch size. think just kind of scanning this and not necessarily like copying what's going here, but I'm using this to kind of like, you look at the appendices sections of these papers and you'll kind of like, while you're thinking and brainstorming about what you need to do, and it'll let you kind of pick the right things to do. So open up a different, what's the one? Okay. Go back or thing and actually, or we go actually plate structure. Okay. So we're working from the outside in. One thing that we need is our kind of data set path, I suppose. We're going to need blocks. So the first part of our training is going to load the set, then create the optimizer, loss function, train the model, or epoch in epochs model. Evaluate the model, save the model. Iterate over the data set. Explanation there. You're going to have forward pass, you're going to have loss, and then you're going to have backward pass. And so there's a function here in the utilities that is going to basically have to take a camera point and then look at, basically sample the camera like space, the visual camera space. So this is a little bit complicated for ChatGPT, but I'm going to try to figure out a way to formulate this in such a way that maybe it can you write a Python function for me that calculates the function that that takes in a camera position and orientation and calculates the ray and calculates rays that traverse through a virtual camera plane, a virtual image plane, plane of a given pixel width height. The rays need to have an origin and a orientation or direction, I guess. It's not great, but we'll see what ChatGPT. Okay, so it's using NumPy. It's giving us this function here, get image plane rays. It has the position, the orientation, the pixel width, pixel height, and focal length. So this is the cam forward. This is kind of an up vector. You can define a I as, let's say, up vector. This is actually like this. Is it better to torch? Sketch. Calculate the image plane's center point in world space. Calculate the image plane's width and height in world space. Okay. Calculate the image plane's right and up vectors in world space. The cross product of the up. Calculate the image plane's top left corner point in the world space. Calculate the step sizes for the right and the up vectors. Initialize a list to store the rays. Okay, loop through each pixel and calculate the ray. Calculate the ray's origin and direction. And it's appending a ray origin and a ray direction. Okay. We're going to call this the world up vector. I think we're going to split this into a couple different functions. I think we're also put it here. But I kind of want to define a new can you define a torch data type that wraps a named tuple, a torch ray PiTorch data type that wraps a name tube with, or that contains two property, ray origin, or origin, and direction. I kind of want it to be like a data class or a named. Okay, so it's not exactly what I wanted. You write the same thing but with a data class. Okay. Well, actually, first, I don't know if the version of Python have allows that. I import data classes. Data classes. Class foo. You have data classes, that's good. Or a data classes. I feel like there's a better Python data class. Better way to import from data classes. Back here. World up spec. The up direction. A ray, aka vector. So add dimension. That. Can you add dimensionality and constraints to the types on this data class? Okay, yeah, so you food station filtered and coding. Yeah, it's not. It's the prototype version, right? You shouldn't think about it as necessarily the version that you're going to use in your life. You want to basically learn how to use it and then get better at it over time. We have our world up vector. We have our ray. Have get arrays. We have our array data class, which has an origin and direction. Want the camera data class. I'm gonna go refill the coffee and go to the bathroom. So I think the camera orientation. Let's make a class camera object. And we can also say width, height, and it's also going to have focal length. So make data class, I guess. There's the volume. The volume 0. Size. Resolution. But not so you. How I define a default value, a data class property. Here's just one. Fields without a default value cannot. Actually import the imports. And oops. I let's put these comments in our doc strings here. For it. Save that. Array, our camera, and our volume classes. Now we want to get arrays. This. We only want a camera. We have our camera object. We basically and it'll return a list of arrays. So we've kind of OO-ified this entire project, right? OO, object-oriented programming, where you kind of want to think of these objects that are the primitive objects in your solving your problem, and then kind of use those to, I guess. But yeah, now we will go ahead and write here with that. So actually we can probably do a new chat. Ask it, right? Can you rewrite get arrays function, the code below, such that it uses the array and camera data classes? Get rid of the class. One's a little bit long, so we'll see how it does. Okay, so you see here, it's getting the arrays. It's redoing everything with torch operations. Here, torch.cross, cross product. We're just copy pasting because it might fail in a second here because of too much output. Okay. Have our update. Get camera. So first thing it does is it gets the camera direction. Calculate center point in world space. And calculate the image plane width and height. And we're not using the right Python environment here. Environment. Width. Calculate right and vector. Yeah, okay, so actually what's going on here, you have vector, have right, and this is this one. So a lot of times forward vector of the camera actually right hand out, y positive this way, want x to be this way, y to be this way, and then that's where that negative is coming from. Then here, camera right. And actually, forward direct. Right. Have them as global variables, their properties. Direct. Direction vector. Right. Sure. Go get that copy. So let's do something even more crazy. Can you write me Python code that uses matplotlib plot 3D to make a 3D plot of vectors or arrays? Make a 3D plot that visualizes the rays, or visualizes a list of rays where each ray is defined according to okay, so it's using the axis 3D. Go ahead and if name main debugging code for the ray calculation. Import matplotlib, import axis 3D. Normally you wouldn't want imports inside your this part of the code here, but this is just to debug. We just want to kind of visualize and make sure that our function here that ChatGPT wrote that gets the rays actually looks correct. Okay, so we have our ray data class. It generates some random rays and extracts the origin and the direction from each of the rays. Okay. Create a figure and a 3D axis. Okay, so part we do want. Then plot the rays as lines with the origins. Okay, so we're gonna have to modify this a little bit, but we're basically there. So, camera object. Have some that just identity orientation there. It's a rotation matrix that represents. We're gonna have an image width, and height, focal length. Yep, that's it. Get rays for the camera. Yep. and then plot the rate. Or raise in array in and array and get raise axis dot plot. Okay, so it seems like the way that matplotlib does this is it basically lines here. Okay. So in our case, we're gonna do the multiplier and we're gonna say array dot and 0, 1, 2 here. Array dot we definitely don't want 6. Let's do very simple. 2 by 2. And see what that looks like. And we can put this here and we'll say Python utils.py. Torch.c tensor meta object is not subscribed. So ChatGPT lied to us, and we want that is not how you define torch data types. You want a torch type. Torch data type, torch type annotations. So you have torch typing. This is project or a project here. Torch typing, import tensor type. Okay. That. Pip install torch typing, and let's go back to and let's do from torch typing import tensor type. All right, and then here we're gonna have it's gonna need at type check. This isn't what I want. Type annotations in data class. Support data classes in Torch script. Data classes tensor. All right, so this is a nightmare. What we're going to do is we're going to take this. We're going to write a new chat, and we're going to say, can you rewrite these data classes such that they use NumPy instead of PyTorch? Certainly, exclamation mark. Here are the updated data classes using NumPy. Torch type that. You know, maybe not. Maybe not. We'll use it. All right. Now let's go ahead and copy paste these. And let's argument must be a tensor, not a and problem here is that, and now this also makes sense. So whenever ChatGPT changed this from np dot product, it remember we used to have it like this 0, 0, 1, but because it used the matrix multiply, it needed to basically transpose this matrix. So that's why it your format. So go ahead and remake it the original format. Make this a type actually world vector well by a vector also by array dot orient dot array run this. List object cannot be interpreted as what? Can you write Python code for me that creates a orientation matrix for a camera object initialized to a 3x3 NumPy array. It's not ND array, sorry. It's Can you modify this line of code such that the forward direction vector is transposed, leading interesting. We didn't even give it the forward. Started doing. All right, torch.cross. Cross. Here, and let's say NumPy cross product. It is np.cross. Also right direction. Okay, so line 51 in getRaise, incompatible dimensions for cross product. Suppose rerun this. And now line 51 in getRaise, still the same line. Right direction vector, 0, 1, 0, or forward. I think the problem is that back to I think we're like our dimensions. Go back here, and it was np dot. Got it with that. Then it was np cross. This. camera orientation, 3x3 rotation matrix that represents the camera's face. Shapes are 3x3 and 1x3. You need the, so this is wrong here in ChatGPT. This does not work. And then you get to here where now your forward is also 3x3. Okay, no, I know what the problem is here. I multiplied 1x3 times the 3x3, and then you end up with a 1x3. Right? That's the forward direction. And then the right is going to be the camera forward direction times the camera right direction vector. Cam forward is going to be 1x3. Right direction vector is going to be a 1x3 as well. So this and get raise. Incompatible dimension or cross product. So write me Python code that takes a NumPy vector and rotates it with a 3x3 rotation matrix. On ChatGPT. So, I mean, now that we know that there's all kinds of mistakes in this, we should need to be a little bit more careful. Yeah, let's try this. This is correct here. Why is this not? Oh, no, you want the camera orientation. Does this even work? I don't think this works. Right here at the thing here. Oh, I know what happened here. happened. There's extra brackets. So there was like a batch dimension. But okay. Found the bug, guys. Here. On here, there's extra brackets. Now let's actually go ahead and run this. All right, perfect. Zip and then And we're back. Sorry about all the introduction or all the breaks today, guys. Guess this shows you how you actually program, right? And you take a bunch of breaks. Okay, so we're here. We figured out the bug with orientation, direction vector. Now we're basically onto here. So line 133 in this get raise function, and then line 76 ray direction dot divide equals ray torch dot norm. I dot norm. I think we killed ChatGPT. So np.linalg linear algebra.norm. One needs to tell NumPy to put that function np namespace. Go. Alrighty, look at this. So we have so a new chat. We're gonna ask it to can you make sure this 3D matplotlib figure always has it's like basically you want all the dimensions to be the same. You don't want them to be squashed. I like as a 1:1 aspect ratio. All right. Set the aspect ratio to 1:1. All right, so our thing, rerun this. Reported values are equal. Equal. All right, so now we have equal aspect ratio. We have our 4 little dots. We have our camera, which is this dot here in the center. And it has the 4x4 dots here. So do 28 by 28, which is the size of MNIST. Again, here the camera's on 0, 0. This. That. So there are our beautiful little rays that are all projecting from the center of the camera into the pixel, right? And this is a pinhole camera model. So let's think about 3D here. So I kind of want to open Blend. It's worth opening Blender right now. Over 2 hours. Oh. I feel like if I make these streams too long, nobody watches them, but the next step. Oh. Let's say open up Blend. And in Blender here, I just love Blender because it's free, it's open source, you can use it. It's actually quite powerful. So what we're going to be using Blender for is we're going to be looking at this camera. And you can actually look at the camera like this. So that's what the camera's seeing right now. And you can take this camera object, bigger, but we want to start thinking about actual dimensions. This cube is in position 0, 0, 0. Its size 1, 1, 1. And we're going to pretend that this is the kind of volume that we're going to ultimately render here. So one thing we can do here is take this camera and let's say 0, 0, and then let's make it 2 up, but let's also make it actually that's kind of where our camera is now. And now we want to orient it a little bit hit RZ, and that allows us to rotate it in dimension. Do that out here. So now you see our camera like this. Let's go ahead and maybe pitch it a little bit more too. So direction RY, IRX, pitch it so that. And let's go ahead and get the ChatGPT knows anything about Blender. Can you complete this Python code for me? Import Y, get the camera object called camera, and print its 8 by 3 rotation matrix. Right. BPY is the Python API for Blender. So here we're going to be getting the object called camera. We're going to print the 3x3 rotation of the object. So go ahead and copy that. Let's actually make a new file here. We're going to scene manip. We're going to need to install bpy. Install by. Pip install our cursor. That's not working. Reason. No matching no matching distribution. Our Chrome, let's open up and pip install bpy nothing. Python NP API. Quick start. Concepts. Install Blender by with pip. Oh no, this is only Python 3.8 or less. Pip install bpy. Oh no, guys, we're not going to be able. All right. Well, we don't need it to do what we want. Dot camera and we got tricks world. And here is our 3x3 matrix for this camera that we oriented in Blender. Fills. Let's put our new camera matrix in. Here we're going to delete that. Put it in square bracket or brackets and all right. Our camera is not at 0. Our at we go back to Blender. Our camera is at 0, -2. code 0. About that. Right, I guess there. C dev pym activate clear, and then Python utils. All right. Or what we were. So we have our camera, which is of course at -2.2, and it's projecting out the pixels. See there, one ray for each pixel, and 28 by 28, and that's correct. Okay. Again, this is basically the camera that we're emulating, calculating what the rays for each of these pixels. Why don't we go ahead and working ray calculate. So what else? What do we want to tackle with volumes? Have our model class function, class function. Origin. So maybe a question here is, how do we normalize direction origin? In our utility function, or maybe as part of the array data class, we're going to have to basically find a function that says input. So this is just naively concatenating, but I think normalize a direction, and then normalize origin. This is not how you're going to normalize the ray origin. The ray origin going to be in based on world size. The camera is also going to have to be normalized. normalized. We're also going to have to turn the camera. Maybe we should have these normalization functions as part of the volume data class. Have a normalize and have some position. Calculate the volume's center point in world space. Calculate the position relative to the volume's center point, and then normalize the position according to size. Kind of what we want. Could have go back to our README, our camera or our neural network here. It's going to have the inputs are going to be the ray direction and the ray origin. So we're going to be evaluating our neural network for ray. Does that make sense, or do we want to do it for every ray? No, the neural network is not taking in the ray direction, ray origin. The neural network is only taking in a position. Because the neural network is evaluated at every point. Yeah, you see here f theta, neural network here, is evaluated on each of these black dots. And each of these black dots is some position in 3D space, along with the view direction of the ray coming at that. So the input to the neural network is a point within the volume, and the view direction of that in world space. So point within volume. This is going to be XYZ. And the view direction is going to be they have 2 dimensions here, so I think you just reduce this to 2 dimensions. Let's say data. Okay, and what are we normalizing these? I think that's right. Are we normalizing these 1, 0 to 1? Not immediate, right? So we need a function that given a ray, and a volume, calculate the intersection point between the ray and the volume, sample endpoints along the ray that are within volume. So this is what GitHub Copilot's telling you. So sample a volume along the ray, calculate the ray's direction in volume space, tab here, and then this. Orientation of the volume and the ray direction. Calculate the ray's origin in the volume space. Kind of got stuck in this weird loop where it's values. I don't get that's one. You don't want that repeated. Calculate the ray's origin in space. I don't think that. Yeah, this is. So Copilot kind of failed here. Let's see if ChatGPT. Chrome again. Our ChatGPT, we're gonna chat. We're gonna give it our ray. And you finish this Python program for me. Okay. Home. And we have the then we want all right. So let's see what ChatGPT. It's going to use NP linspace to generate a list of evenly spaced samples along the ray. Then you can use volume.position and volume.size properties to check if each sample is within the volume. If it is, you add it to a list. Here's some code to illustrate what I mean. Sample points in. All right. You obviously don't want to say. Let's start with something. Samples equals NP linspace 0 to 1 in the number of samples. Okay. initialize an empty list to store the points. Okay. Okay, perfect. Copy. So ChatGPT made a much better attempt at this than Pilot. Okay, for sample, calculate the point directions, origin of the ray plus the direction. I think it's a little bit more complicated. Yeah. This is more complicated. And that are with that. Can you modify the function above so that it always samples endpoints within the volume, instead of just sampling points along the array and checking if they are inside the volume? That is not what I want. That is not what I wanted, and I think we also need to modify this function in a different. So we want return points, or we first want to know. Calculated volume and calculate u direction of the. Also not correct. Actually going to turn a of points. Okay. make a new data class and have a position, color, view angle, and it's also going to have an opacity. And these are going to be the objects that we right, the neural network is going to take in the view angle and the position. They're going to be inputs to neural net, and then the outputs from neural net are going to be the color and the opacity. So you're going to have a 5-dimensional input and a 4-dimensional output. Or get list. Another function that we're going to need here is, not sure, phrase, then we're going to we're going to take a break from point and wrap. Go into our model. Make a new chat. And let's simply do this, and then put a little class description. Neural Radiance model. Takes as input 5 tensor of shape. Input is batch size 5. Output is going to be batch size 4. The input going to be a output color opacity. Imports. We're going to give it to ChatGPT, and we're going to see what it does for the rest of this. Okay, it's just kind of giving a summary of what a NeRF is. Yes, can you implement the model class for me? Okay, it's using the functional API here. Putting ReLUs in between them, except for the last layer. So that's what ChatGPT gives us, our little NeRF model. A num layer. We'll say keeps wanting to do a tiny, so num 50. Nice for the hidden layers, just arbitrarily. Do input size 5, and then output size is going. Our input size is going to be this. Our output size is this. Okay, nice NeRF model. We're effectively at the 3-hour mark, so I'm actually going to stop here to go lunch. Maybe I come back. Don't. But thanks for listening so far. And yeah, we'll continue to do this coding probably tomorrow, maybe even this afternoon. So thanks for that, guys.